So in this class, this is week 9 session class. So
Yes,
we have
sir.
discussed, yeah.
No, no.
So we will discuss about the clean room, that cancer diagnostic tool, pressure
Mm-hmm.
sensor, stepper motor,
Okay.
and if time will be permitted, then we can do further discussions. So first we take your doubt, anything or doubt regarding that.
Yes, sir. 1 minute. I had doubt in week one.
Week one.
Actually, yeah, today I was studying week one, so I had few doubt.
Yes, yes. Tell me.
One, 1 minute. I will. So, sir, actually, so I had a doubt. Like, we have both sensor and a transducer, right?
Yes.
So, are sensors part of transducer or transducer part of sensor? Like, which one is part of which one?
Both are independent component.
Both, are you saying both are independent?
Component. Sensor
Oh,
sensor will just sense the physical stimulus. Transducer will be translate that physical stimulus in from one form to another form.
okay. So,
Like that, your sensor will be like that. Suppose that your sensor will be gas sensor. It will be gas. It will be sense the gas. Now, how you analyze that data? So you want
okay,
that physical form into either in the electrical form, either in the magnetical form, either in whatever form you want to like. That will be converted by the transducer.
okay. So basically, the transducer converts some physical form like gas to electrical quantity, right?
Yes, yes, electrical or
So,
mechanical, whatever quantity you want
so
to.
you can say the sensor is also a transducer.
Yes,
Oh, okay.
but both are the independent component. We have to design both are separately, and then we have to integrate it in the completely system.
Okay. So as in the slide, like they have placed it two or more transducer to
Yes,
convert one form of energy to another, and then they finally they put a direct sensor
yes,
to
yes.
measure the electrical.
Yes.
Okay, okay.
Okay.
Hmm.
Any other things?
Hmm. 1 minute. And what is Seebeck and Peltier effect, sir? Seebeck and Peltier.
Seebeck and Pitler effect, that is depend upon the temperature. It
Depending
will be
upon
used
time.
in the thermoelectric and thermo that.
Yeah, I had just thought like, hmm.
One, uh, like that, feedback effect is like that. We have the two electrode, okay, parallel
O-
electrode,
okay,
okay.
sir. Hmm.
So what will happen that due to the heating, there will be some difference of the heating will be happen in the two electrode. Temperature depends between the two different electrical semiconductor will be there. So
Okay.
to measure uh, to measure that difference of the electric field, we can that electric field will be created due to temperature is that feedback effect.
Oh, electric field will be created due to the temperature
Yes,
difference.
yes.
Okay.
Okay.
Okay,
So
sir.
we have to provide a heating source,
Mm-hmm.
and in so Pitler effect is also due to the heating like that. I will share my slide.
Yes, sir.
It is visible.
Yeah, visible.
So what will happen in the feedback effect like that? We have a semiconductor material. This is N type and this is P type semiconductor material. Okay,
Okay.
and
Okay.
we have one heat source like that. We want to heat.
So we are
Okay,
heating the both the material at the same time.
we
And
provide a heating. That's a thermoelectric effect. We have saved that feedback. Okay,
okay.
and
Okay.
this side we have one cool side. Okay,
Mm-hmm.
and here we have to measure the voltage difference between this. So electron
Oh,
will be move like that from P to N junction. Okay, current will
okay.
be generated and we have to measure, and this will be happen due to that thermoelectric effect. And whatever the generated electrons difference of the electromagnetic field electric field generated minus S upon delta T. S is the sensitivity of material and delta T is the difference of the temperatures in case
Ah,
of that feedback effect. Okay.
okay. Okay.
In
And
case of the Pittler effect, in case of this heat surface, uh, we have the either here we have the cool surface, and there will be heat dissipation. In the below that we provide one heat dissipation. So due to the difference of the heat between that N and P junction due to the heating and cooling effect, we generated the current per unit time in between that two junction, and the heating coefficient should be equal to that junction A coefficient of that Pittler coefficient minus junction B Pittler coefficient.
this one is quite difficult to
Means
understand.
this is the some semiconductor material have the some Pittler coefficient, different Pittler coefficient they have.
Mm-hmm.
Okay. So what is the
Okay.
difference that quantity of the heat generated will be difference of that Pittler coefficient of that semiconductor in that case. But in case of the feedback effect, it is the coefficient thermal coefficient of that material with the difference of that heat between the two electrode.
Okay.
Okay.
Hmm. Okay,
So
sir.
it will be in this case we measure the heat in a feedback in reference to the current or voltage. Here we measure in the difference of the charge. How much the charge will be generated due to the difference of the heat in the semiconductor materials.
So the for Peltier we are measuring the charge, and for Seebeck we are measuring which one,
Current,
sir?
current or voltage.
Current or voltage. Okay.
Either we measure the voltage or current EMF generated, that electric field generated.
Mm-hmm. Okay. Mm. And then what is the absolute and relative scale error? The week one problem solving session you have mentioned the relative and absolute, uh,
Absolute
relative and
means
mm,
absolute means that it is standard. Okay. Relative means we have take the 10 to 3 times, we have measured that like that we measure the temperature around 10 times. Okay. In the first sample, we got the temperature like that 50 degrees Celsius. In second, we got 51. In third, 52, 53, like that 48,
okay,
47.
okay,
So we take the
okay,
relative that how much the relative error will be there in that case. In the suppose that our absolute temperature should be like that 50 degrees Celsius. Okay.
okay, okay. Oh,
So
absolute
suppose
is
that
a kind of
we got a 50.8, yeah, 49.8. So what is the difference between error? We take this is the we take the root mean square of all the errors, and then we have to calculate that this is the
so
relative error of my device.
okay, and absolute is the kind of the ideal value, like
Ideal
so absolute when it
like
was
that is someone people will be assigned that this is the like that like that we have to buy the resistor, and some people say that it is 1 kilo ohm plus minus 2%.
yeah, 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 yes, sir.
Okay.
Okay,
Some people
so
write at plus minus 5%, some people minus plus minus 10%.
okay. So
That is.
absolute is like the, for example, in case of the micro heater, we need to have the temperature at around 37 degrees Celsius, right?
Yeah.
So that 37 is the absolute temperature. And when we
Someone said
actually,
that error will be 1%, absolute error should be 1%. It will be 30.3% should be increased. But maybe they said that a relative error should be 5%. So you can say that a relative error should be go to that 30.5 that temperature.
okay, so
Make
relative error
it,
is kind of taking lot of readings and measuring the absolute mean value.
yes, yes.
And okay, okay, sir. Yes, sir. Mm, yeah,
So
that's
we
all,
get the
sir.
root mean square of that error, everything that.
Okay, okay. So we want which one, sir? We want absolute or relative one? We want absolute value, right?
Yeah, some because people are because instrument will be not accurate every time. So people are maybe that relative error should be they have considered every time.
Oh, okay, okay.
Okay, this much error will be then my instrument is okay, my reading is okay.
Mm, okay, okay.
Okay.
And yeah, and also in one thing like they have said like we need to take a glass substrate and we put some the tissues and we need to mince or slice using another glass substrate. What do you mean by that, sir?
What you said?
Oh, 1 minute, sir. I'm taking my notes.
It is assignment or some they have?
No, no, actually, sir is 1 minute. It is not like assignment.
Okay.
Like in one video, Sir has mentioned like we are taking a glass substrate, okay? We are taking glass, and we are also taking the affected cells, like cancerous cells, and we are
Okay.
putting it into putting on top of the glass,
Hmm.
and using another glass slide, we are smearing it, okay?
Means
And
like that smelling like they have that they have like have you taken that blood sample on the glass?
Yeah, like I have seen the blood sample. Yeah, okay. In
Some
that.
people will take some people like that when you go to the hospital that nursing staff will be stuck with a syringe here and they take
Mm-hmm.
a droplets on the glass and
Yeah,
then after
yeah.
they take under the glass and they spilled on the whole surface of the glass.
Oh, so yes. So smearing it means actually spreading.
Spreading with another glass so it will be on the whole glass and we can check in the microscope that
Ah,
even single cell we can see otherwise it will be thick there and we cannot identify.
okay, 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 okay. Now I understand. And then we are taking the staining agent. So what is the staining agent? Here he said
that
like
will
HND.
that will be helpful to that circulate that like that in the solvent we use that in case of the photoresist or resin we
Uh,
can use in case of the photoresist.
okay, so here.
Here will we take the one solvent which will be helpful to identify that either they magnifying that images they will be protecting from that any reaction or they can be
Ah.
their cells will be thick they will be helpful to the spread on the whole surface with uniformity.
Oh, so staining agent is helpful for magnifying or also spreading those cells and protecting
Yes.
against any reaction.
Yes. Yes.
Oh, okay, okay. And
Okay.
and he has said something about mammography. So can you explain mammography for me?
Mammography like that it is the tool of that cancer diagnosed.
So like it is
One is
like mm.
one they have said that cartology and one is mammography.
Oh, no, not catology. No, sir.
Then
What is cat? No, they have said like actually, when you go for a hospital, you will check using the mammography and identify the affected area. Then using the biopsy, take the syringe and using microtome, you split the cells and you just measure the various quantities.
like that have you like that mammography is like that X-ray tube like that X-ray. Okay.
Oh, okay, okay,
So a woman have like that it will be generally used to detect the breast cancer in the woman.
okay.
Breast
Mhm.
cancer cells. Someone will be that biopsy will be done. After that, they have if they have not identified in the mammography. So they will
Ah,
take the one cut of that tissue of that from the breast cells, and they'll go send for the biopsy. Okay.
oh, yes, sir.
So what will be happen that if a woman have no sign or symptoms of that of any breast cancer,
Mm-hmm.
ठीक है ना? So they primarily they use the screening of that primary screening of that disease that,
Oh, okay.
ठीक है? So
Yes,
they
sir.
will
Yes,
just
sir.
take a X-ray of that breast or that tissue, and then they identify that in the
Mm-hmm.
if the there will be any clean things, then there will no tissue. If some will be dark or white spot will be there when the X-ray will be fall. It means there will be some tissue. Hi Pritam. Hello. Good evening, Pritam.
Hi, sir.
Hello. How are you?
Fine, sir. Or how are you?
I am also good.
Okay, sorry, I was late little bit.
No, no, no problem. You are busy with family and
Yes, you understood.
yes, yes. So, like that in the X-ray, like that when you have some fracture in your hand, what Pritam? Answer B. Actually, I have discussed something different, Pritam.
Okay, sir.
I will take the questions after that. Actually, Sudarshan have some doubts, so I will clear that first and then go for that.
Sir, fine.
So, Sudarshan, like that, have you seen that X-ray of any fracture people?
The X-rays, the X-ray sheet, right?
If
Like,
you have the in-hand fracture and you take the X-ray,
we have X-ray sheet, black and white.
like in COVID, you will see that they have taken the chest X-ray
Yeah,
for two.
yeah,
So
yeah, for
they
the
have
lungs.
like that. Our lungs will be black, black. If the X-ray will be
Hmm.
clear, it should be the black, like that greenish gray color, like the light gray color. But when it
Okay.
will some fold, it will have some white, white particle will be there, or some white will be there.
Ah, okay, okay,
Same like that, if the breast have the some cancer cells and anything that when the X-ray will be fall, it will be either in the white dot or black dot.
okay. So mammography is only for the specific kind of disease, or it is used as similar as X-ray?
No, no, it is for the cancer sign only, for cancer, breast
Oh,
cancer. They
for
especially use for the breast cancer.
so it is specifically for diagnosing the cancer.
Cancer. So
Okay,
that's why
okay.
the name is memo.
Ah, okay,
Name itself, the mammogram is memo. They have the scientific name of the breast. They said like memo.
okay, okay. Oh,
Okay.
mm-hmm.
So
Yes,
that
sir.
glance means X-ray. Memo means breast X-ray.
Okay, okay. Now I understood. Mm. Yes,
Okay.
sir. Yeah.
And like that, absolute error should be measured like that. Some people have that. Actual value should be like that like the temperature actual value will be 30 degrees celsius, and I have measured the value like that 35 degrees celsius. So absolute
Okay.
error will be 35 minus 30 upon 30. Okay.
Oh, okay, okay.
And we were measure the relative value means we divide the whole absolute value. Okay.
Mm-hmm.
And like that like relative error we measure like we divide with this absolute value with the actual value
Ah, for relative.
for relative.
Okay,
Okay.
okay. Yes, sir. Yes, sir.
Anything else?
No, sir. I just had any that kind of
Uttam,
thing.
have you any doubt?
No, sir.
I think one people he will left like that. So can we discuss some question and then we go for some clean room parts
Yes,
and everything.
yes, sir. Yes, sir. We can discuss.
So I think that if you have to go to the video, they have mentioned the 4 to 5 video about the clean room and everything that. So what is the
Yeah.
primary source of contamination in the clean room?
Primary source people.
Why?
Because we are having the skin flakes and our hair can fall on the clean room and the dust when we walk there will be dust, and yeah, those kind of things.
Okay. What view about your Pritam? Yeah.
Because people are moving from outside to the clean room, so they have a carrier for the contamination.
Yeah, contamination.
So how to avoid that things we can?
Like we need to wear protective gears.
So what we should do that? What can we use the in a clean room facility that the contamination will be removed from the people's that they have
Like
not carry any particles size of the 10 micrometer or more that 40 micrometer 100 micrometer.
yes, sir. Like we have the protective gear like from the hair. How to say that? From to tie up the hair and put the how to say to
The
put the
governing
gowning.
procedure.
Yeah,
Yeah.
gowning procedure. Gowning.
So there is a yes, you have to wear the apron. You have to wear the
Mm-hmm.
head cap on that your head. You have to wear
Gloves.
Yes.
the gloves. You have to wear that when you have to enter in the clean room. You have to pull out your shoes, socks, and you have to wear that shoes. Yeah, the slipper they have already put in the clean room. You have to wear the slipper mask in your head, in your foot, and there is a one that blower should be there, that air blower will be there. You have to keep you have to stand 4 to 5 minutes in that, and then machine will be automatically will start, it will suck out all the particles from your body. Okay.
The air
Yes,
bath.
sir.
Yeah. So it have the two flow. One is the turbulent flow, and one is opposite flow. Will be that technology will be there. That turbulent flow of that air will be take place. So whole the clean room have the flow of the turbulent flow of that air in that. So it will be when air will be come, it will with the turbulent flow that they suck the dust particle and everything. So they have the some HEPA filter will be there installed in the clean room, or some they have the HEPA filter for gases and particles for both things. So I think that Pritam, you have the experience of the clean room. You visited in the IT.
I have experience in some work was there in the SCL Chandigarh, so I gone there in the fab, but
Okay,
I
okay.
did not use any air bath or that kind of thing in IIT Delhi. IIT Delhi, in the Department of Care, they have a simple governing things only.
Yes, yes. Like that, maybe that is a class of the 100 or 10,000 thousand class of the clean room in the ITB, ITD.
Yes. Yes.
If you go for the class 1,000 and class, upper class, it
100.
should be compulsory.
Yes.
Okay.
What kind of clean room available in your lab, sir? IIT Jodhpur.
We have not still the clean room. We have maybe that within a 2 year, yeah, 2 and 3 years, it will be constructed.
Sir,
We have we have
how
the
big?
class 10,000 clean room in the IT Jodhpur.
Okay, so okay,
We
sir.
are just taking only. We have to wear the apron and everything. We have to take care, but not the clean life facility. We have clean room.
Okay, okay. Yes, sir.
Okay. So still we are waiting for that facility.
Oh, no, sir.
No, no, it is compulsory for device and everything. Otherwise, you have to not work for the bio people, chemistry people, and for fabrication, MEMS. Otherwise,
Yeah,
device property will be changed or it will be not work.
yeah.
And for safety purpose, you have to work only the clean room. Otherwise, you have to maybe in the dangers for you also that, because there are a
Hmm.
lot of the chemicals that you have usage is harmful for you. Like that photoresist, I already told you that if you continually exposure in the positive or negative photoresist, it will cause the cancers and mainly problem with the infertility in the women's and men's.
Oh. Also, the clean rooms are the lightings in the clean rooms are kind of yellowish in color. So why is it like that?
That for the photoresist only, not for whole the clean room.
No, I saw some YouTube video and
Yes,
they
they are
have.
they are using a spin coater and some chemicals. They are because some chemicals are active on the presence of the light. They can be react and then change the property. So yellow light
Oh,
will be
okay.
suitable. They have not react with the yellow light particularly.
Okay, okay.
I think
That's why
yellow room they use in litho room, I think.
yes, a lithography because you use the photoresist. Photoresist is the reacting with the light.
Sensitive to.
Yeah, light
Hmm.
sensitive because the
Oh,
source of that is optical source for that to expose the pattern.
yes, sir. Yes, sir.
So in mainly the lithography people are using a yellow light. Otherwise, it should be the white light everywhere.
Oh, okay, sir. Yes, sir.
Okay.
Yeah, understood.
So next question.
Excuse me, sir.
Yes.
Sir, what kind of questions we shall we expect, sir? Do we have any mock test like in NPTEL?
For
What type of
exam or what you have to ask.
for exams, sir? For exam, main exams.
So it is just like that. Have you attempted the quiz?
Sir, you are telling that assignment, no, sir?
Yes, yes. Assignment quiz.
Weekly assignments. Yes, sir. Yes, sir.
So view by assignment like that question will become your like objective question will become MCQ type.
Okay, sir.
Okay.
Okay,
So
sir.
Whole
maybe
exam will be multiple choice.
yes, yes. Whole exam will be multiple choice.
Okay.
Okay, sir. Sir,
So it
how
is
should we prepare, sir? Should we prepare whole? We have to see the whole ledgers or else any
You,
PPTs are available for this course, sir. Some of the courses they are telling PPTs are available.
like my PPT is available to you easily access and in the like that in the SWAM portal you see the transcript of that everything that you
Sir,
can
I
download
am
the
asking
transcript.
any PPT, sir. Transcript is somewhat more pages, no, sir. That's
No, no,
why
we will
I'm.
discuss from the transcript only that because the faculty will be prepare the paper from that transcript.
Okay, sir. Okay.
So my
You
PPT will
can
be
take out a screenshot.
yeah.
yeah, you need to take the
You
screen.
can take a screenshot when sir started teaching.
Yes, yes.
Okay,
Either you have to go the video and you make your own hand notes
okay,
when
sir. Okay,
or you go through the transcript because they are just asking the questions like that in the assignment like that only.
okay, sir. Okay.
Okay.
Thank you, sir.
Or even I have explained in my video more depthly like that. Sir will be only touch the portion of that. There is some more, like a more video in their lectures like that clean room, how that Arduino will be worked with the sensors. So they have everything they will be explained through the video only. Even I have included some Arduino part in my PPT also that.
Yes, sir. Your PPT is kind of more advanced.
Yeah, because I have taken some advanced version of that.
Yeah, yeah, yeah.
Sir will just touch the basic portion of that everything.
Yes, sir.
So Karthik, I think you have joined the first time.
Which one, sir? Meeting, sir? G meet.
This the live class.
Yes, sir. Yes, sir.
So from where are you?
Tirthani, sir.
Yeah.
Tirthani. Near
Which is
Arkonam, sir. Tiruvallur district.
Ernakulam, Kerala.
Sir, Tamil
Tamil
Nadu.
Nadu, Tamil Nadu, sir.
So Tamil Nadu. Sorry, sorry.
Uh,
So you are PhD scholar or BTech?
BTech, sir. BTech.
Okay, BTech final year.
Third year, sir.
Okay, okay, third year. So you can go through the my video that they have shared your link that Google Drive link that I have already uploaded and give the permission to everyone.
We are
My
already
yes.
PPT,
uploaded, sir.
yes, my PPT is accessible to you. My video is accessible to you. You can subscribe my channel also.
In
No
YouTube,
problem.
sir.
YouTube.
Sir, channel name, sir.
Uh, you can that Ashok P19EE203.
Sir, okay, sir. Thank you.
That Sudarshan have shared you that link also. That I think that
Like the spreadsheet, in that
yeah,
you can have the YouTube link.
yeah, YouTube link and Google that PPT link both.
Yeah.
Okay.
Okay, sir. Thank you, sir.
So Yes, Pritam, you are right that that classification that motor will be based on the type of the winding. So yeah, either it will be uniform or bipolar means they have the two poles or one poles. One is north or south poles, and some like that four that motor will become in the four step, six step, eight step motor will become. So it will be depend upon the winding of that motors, that copper winding they are using, and that electromagnetic field will be generated between the two magnetic poles will be uh, responsible for that movement of the motors. That
Yes, sir.
so the current way of identifying the diagonist in the sense 1 minute maybe. Uh, 1 minute. So, can you tell me the current way of identify the diagnosis in the cancers? How will be, what is the way and the tools to be we can diagnose the cancer in the human being?
Sir, you are saying the tools or how to identify
No,
the
no,
cancer?
diagnose, to identify that.
To identify.
Method we have to use, or what are the instrument which are used to.
Hmm. So basically, we need to go for hospital and for diagnosis, use mammography, identify the affected part, and using the biopsy, take the tissue from the affected part, and using microtome, you need to split those tissue into several things, and you need to different apply different biomarkers for identifying whether it is biennial epithelial or yeah other kind of things, and you also have H&E markers, and then you also put another kind of the same part of tissue in interdigitated electrode, and then you can measure the impedance based upon its elasticity, the resistivity can change.
Yes, yes, you are right. So one way is the screening, and a second way is called a diagnosis. First, we have to do screening, and then we have to do diagnosis. Okay.
Oh, yeah, I said like the same thing, the screening.
Yes, yes. So screening is the ASA work, that is the primary that nursing staff will can take workers will take the cells from the region which is affected. If the cells could be smeared, that means you take the glass slide, load the cell, take another glass and smear it. Means it you have to make the that separate it that every cells that. Then the
Mm-hmm.
individual said they are stand with the that you have taken H and E before you smear diagonist it with the H and E, which is a starting agent that will be used to react with that either with the X-ray or some that tools that biopsy that. So they you have to add the H and E reagent in that cells that. Okay.
Yes,
And
sir.
then each cell is observed under the microscope by the 10 oncologists. So they have checked the morphology of that, how the cell morphology will be changed. That they have like they have the standard cells already they have in their system, and whatever that patient cells they have compared with that, and they see that there is a which type of the cancer cells will be present in that human being. Okay. So change in the shape of the cells, right, can result in the next step in the cancers. So next step we show the diagnosis. If the cells are same, it is okay. If there is a double nucleation cell to the cytoplasma ratio, change in the shape of the cells, as I said earlier, and there are 6 different parameters that people have to understand. If one of the parameters is identified on the glass cell which is smeared with the cells, then the outcomes are reported like that. I show the images of cell like that. They have taken the samples like that and they have spread on that glass slides. So this is taken from that some university Mac, the Michael A. Can, they have reported in their papers. And
Okay.
this is the normal smear. You can check that how the people will smear that that tissue or cells. and this is the normal squamous cells. When they have checked with the microscope, it will be seen like that only. Okay,
Okay.
and then it will be metaplastic cells like that. This is the diagnosis that this is the metaplastic cells will be there for that generation of the region for that cancers that.
Okay.
So you can check in through the microscope or some like that. Now FESAM or SAM will be there, so you can check the images in that. How your morphology of that cells will be changes.
Okay.
So this is the carcinoma. This is red.
Is
We have
it the cancer cell, sir?
yeah,
Carcinoma?
carcinoma. This is name of that cancer, that carcinoma.
Okay.
Okay.
Yeah.
So now we have to discuss about the clean room. So the clean room, the concentration of the airborne particle is controlled. Means that that particle come from the airs or some that external or internal source will be there for generation of the particles or that humidity, some radiations will be there, some temperatures or some pressure effect will be also there outside that, so we have to maintain everything in that clean room. So constructed and used in a manner to minimize the introduction, generation and retention of the particle inside the room. So other parameter, temperature, humidity and pressure are also controlled. So clean room are one or more clean zones together with all associated structure. It is one room type structures. I will show you video also, small video. So we have divided the clean room as per the ISO standard or USA or European standard. So we have name nomenclature like that: class 1, class 10, class 100, class 1000. That it will depend upon the particle size per cubic feet will be available in the clean room. Means that if the 1000 class clean room will be there, so 1000 particle per cubic meter per cubic feet will be acceptable in that case. Okay, so if
Yes,
the
sir. Yes,
1000
sir.
micrometer particles should be acceptable in that case, in that if that class 1000 will be there. So the range of the particles should be that 0.1 to that 5 micrometers. So occupancy state, installation is complete, all the service functioning, no production equipment materials that are present, no personal present, that in the occupy state already, that we have no one will be there or machine will be there only, that in that case. So source of the contamination in the clean room, so it is the external source or internal source. So it encompasses the following: that another is the internal source is the atmosphere, like dust, droplets like that, water particles, water droplets or some VOCs droplets will be there inside that clean room. Free organism, that bacteria, tissue, cells, microbiology component will be there. So operator, this include like that another internal source we like that, we when we have to breathing out and breathing in, some bacteria or some nano enzymes will be come on the outside that surface. So we have to wear that time mask, that face mask we have to already our time we have to wear in that case. The hands, that we have to touch some things, that so we have to wear the gloves to avoid that. Clothing, that our that wearing that clothing, so we have to wear the apron that will be clean. The hairs, the working surface equipment or raw materials, these are all the sources through which the impurity will be generated, so we have to minimize through this clean room. So external source, for any given space, external source exit externally and influence the gross atmospheric contamination, like air conditioning system, makeup air that we have to use, building doors, window, cracks and wall, pipes, cable and ducts. They have also contain some dust particle on that cable, and some pipes will be also generated. They have meanwhile with the timing, dust particle will be deposited on the pipes, cracks on the walls. So some like the cement and concrete will be come out windows, let outer air will be come through the window, some dust will become, that is the external source. So internal source, atmosphere, the atmosphere has no flora of its own. So growth of the microorganism heavily contaminated with particles will become with the atmosphere. Uh, Dust droplets of that respiratory by cupping or sneezing, some that droplets come from our nose will be also that free organism, bacteria and virus that I have already discussed. Operator that breathing that or hands that 1,000 organisms per square meter will be through the skin, that will be clothing fibers, or that cloth fibers will be drop inside that room also. Hairs. So the particle cleanness of the air shall be defined in one year more. That how can we decide that size of that clean room, that Cn equal to 10 to the power n into 0 to 1 upon d to 208. So in which n is the ISO classification number, which shall be not exceed a value of 9, ISO class 1 to 9. So we have defined the clean room from class 1 to 9. So C1, if the for each considered particle, so it should be D. So we can identify that which clean room will be there. From that, if we want to generate one class 9 clean room, then we put the n9 10 to the power 9 into, through that we can identify that how much the particle size should be acceptable per square per cubic feet. So this is the available standard, and differentiate the size of the clean room, that ISO class 1. So it will be 0 to 1 micrometers maximum concentration limit particles per meter cube of the airs. So 10 micrometers of 10 class, that ISO class 2, that particle will be acceptable. 0 to 1 micrometer 10 particles should be there. 0 to 2 particles acceptable. Only 2 particles will be there available. In the class 9, like that, 0 to 4 5 and 5 to that particle size will be increasing, in that case acceptable. So this is the airflow pattern for clean room facility, that I already told you first beginning of that class, that turbulent clean room will be there. So that sucking of that, the HEPA filter will be take that particle, suck the particles and go outside that. And this is the laminar flow in the clean room facilities. So these are happening through that HEPA filter only, that. So I will show you video. So I have taken this, the Dennis Aranda, that USA research scholar. He have uploaded one video of the clean room. So we acknowledge him also, because
Portion
this
of
is
the glove.
copyright issue.
Pull the gloves on. Properly use clean rooms, provided by NASA Langley Research Center. Clean rooms are one of the most valuable tools in limiting contamination of sensitive hardware,
Voice
such
is
as
come.
optics, science instruments, and
I am
spacecraft.
audible.
In this video, you'll learn about
You are
clean
audible,
rooms,
sir.
how to enter and exit a clean
Yes,
room
sir.
properly, and correct procedures for operating in a clean room to ensure minimal
To see that how
contamination.
the people are working in the clean room, sir.
Introduction to clean rooms. What is a clean room? A clean room is a room in which the quantity and size of airborne particles are controlled in order to limit contamination. A clean room is also constructed and operated in a manner to control the introduction, generation, and retention of contaminants inside the space. Filtered air
So
flows
this is the
into the
HEPA
room
filter
through
they are
high
using.
efficiency particulate air, or HEPA
Okay.
filters.
Like that,
Clean
now
rooms are
that
classified based on the amount of
people are working on that fresh air filter will be available in the room and hotel. That what they have said, that name, that people are in the Delhi, that they have to clean the air, they use some devices. I think Pitam, that IIT Delhi have in the clean that
For
Air
homes
filter.
or
air
air
purifier.
filters?
Air
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 purifier.
purifier. Yes,
So
sir. Yes, sir.
in the air purifier, the people are using the HEPA filter to purify that air.
Say, in HEPA filter, it is kind of like we need to change the filter, or it is cleanable by us.
No, we after it will be lifetime, some lifetime. Then we have to replace with the filter. That we have to put new filter.
We need to throw away the existing and you need to buy the filter.
Yes, fresh filter.
Okay.
Like that in AC, we have some filter that they have a clean air will become from the AC. That
But in AC we can clean it now. When it became
but
dusty.
yeah, like that filter will be depend upon that application. Some filter will be used to capture the bacteria also. They also remove
Ah,
the bacteria, gases, and everything. So
okay,
it
okay.
have made of the different materials for the different applications.
Okay, sir. Okay, sir.
Of allowed airborne particles in the room at any given time. The fewer particles allowed,
So
the
see
more
that how
precautions
people
that
will be
must be
wearing
taken
that
in order
their
to
clothes
prevent
and everything
contamination.
that they have removed
There are
that
two
they have wear
different
the
types of
apron.
clean rooms. Hard wall clean rooms have sturdily constructed, rigid walls. Soft wall clean rooms have flexible walls, such as plastic sheets or strips. Hard wall clean rooms are typically cleaner than soft wall, but the processes to avoid contamination are similar in both. Clean rooms can also be classified by the direction of the
So
airflow.
this is the
Some
laminar
clean
and
rooms
that
have
flow, that
horizontal
horizontal,
airflow,
that
in
turbulent
which the
flow of
filtered
that
air
air.
enters at one wall and exits through an opposite wall. Vertical flow clean rooms provide filtered air from the ceiling, and the air flows downwards towards the floor. Clean rooms are classified
So this
under
is
the
the
ISO
class
standard
90 that most clean room, that least
14644.
clean room that.
The
So then you have
classifications
to
are based
ISO
upon
class
the amount
1,
and
then it is the
size of
most clean
airborne
room that.
particles in a clean room at any given time. The ISO standard covers 9 classes of clean rooms, with Class 1 being the cleanest and Class 9 being the least clean. This video primarily covers ISO Class 7 and ISO Class 5 clean rooms,
So
as these are some
mainly
of the most
people
common
that
classes of
now
clean
the in
rooms
the industry
used.
that available the
ISO
class
5
class
clean
5
rooms are
and
much
or
cleaner
some
than ISO 7
research
clean
industry
rooms,
that have
and
the
hence,
ISO class
more
7
precautions
that.
must be taken to limit contamination.
Intel have the class 1 clean room.
Preparing for work in the clean room. A clean room is not an office or a general lab area. Certain items that are perfectly fine in other areas are prohibited in clean rooms. We have to
There's only one difference between truly successful people and unsuccessful people.
properly prepare before gowning up and entering the clean area. First,
So see
remove
that
any
how people will
cardboard,
be that.
paper, or other
You will
fibrous
be
outer
said you are
packaging
not to
from
allowed to
items.
enter in the clean room.
Paper and cardboard excessively shed particles, and fibers are prohibited in clean rooms. Only cleanroom notebooks and cleanroom paper may be used in the clean room. If regular paper must be used, it should be sealed in plastic sheet
So
protectors
this is
or
the
plastic
list
bags.
they have to take care while they
Only
entering in the
ballpoint
clean
pens
room.
without caps should be used in the clean room. Graphite pencils create particles. Next, dispose of any prohibited items, such as paper, trash, etc. Food and drink are also prohibited in clean rooms. If you don't know whether or not an item is prohibited, consult the contamination control engineer or the manager in charge of your clean room. Next, wipe down the
So
outer
that they have to
surfaces of
clean
any
the
tools or
that
hardware that you
instrument and
plan on
everything
bringing
with
into
that
the clean room.
some
This will reduce the
IPA
amount of
and
particles
that
you
is the
introduce
tissue
to the room.
papers, or
If you are
some
carrying the
cloth
items in a
that have the
container,
very
such as a
fine
tote,
fabric.
the outer surfaces of the tote must also be wiped down.
Before entering, so they
Use
have
the
to,
wipes
you have
and
to
solvents
remove
provided
everything
for your
that.
cleanroom area. Wipes may be
This is
pre-moistened
the
or dry
IPA,
wipes with
that
solvents such as
isopropyl alcohol
isopropyl
they have
alcohol
used.
may be used. Once a wipe becomes visibly dirty, discard it in the
Now you
required
have to
container
keep
and
everything.
use a
See
new
that how
wipe.
much the dust will be on the order.
If shoe
that,
cleaners are provided, then use them as
this is
demonstrated.
the that you have to clean your foot. That they have to capture that dust particle, that size of the mm that have,
Put booties on your
and
feet
then
to
you have
prevent
to
tracking
clear
in
that
particles.
on your shoe.
As you enter the cleanroom, take care to step on the adhesive sticky mat, which further prevents particulate contamination.
So this is the that
If
one
the adhesive
cloth
sticky
that
mat
will
is
be
dirty,
secure, that
remove the dirty
anything
layer
dust will be
to
that.
expose a
This sheet
clean
will be-
layer before entering the room. Cleanroom gowning, ISO Class 7 or 8. We are now ready to gown up for the cleanroom. First, we will go over the gowning typically used for an ISO Class 7 or 8 cleanroom environment. However, your specific environment may require more stringent controls. Always check with your contamination control engineer or manager. After entering the gowning room, cleanroom users should always gown up in a top-down manner, starting at the head. First, place the bouffant cap over your hair and ears. Make sure the cap covers all of your hair.
So she wearing
People
that
with long
head
hair
cap.
should tie their hair back before putting on a bouffant cap. Next, put on a face mask, completely
This is a
covering your
mask
nose and mouth.
for breathing.
This limits particles being introduced to the
So your
environment or
droplets from
hardware
the nose,
from our
and when you are
breathing.
sneezing, it will be not drop
Next,
in the
obtain
clean
a
room.
smock, which will usually
Now
be
she will be
provided in a
wearing that
clean sealed
apron.
bag. Cut open the bag with scissors and throw the bag in the trash. Unzip the smock, and put the smock on one sleeve at a time, taking care to make sure the smock does not touch the ground or other surfaces. Zip the smock all the way up and secure any snaps at the neck. Be sure to choose a smock size that fits comfortably, not too big and not too small. Finally, obtain clean
See the gloves?
The specific type of glove approved for your area depends on the hardware and operations you will be performing. Always handle gloves by the gauntlet, and do not touch the finger and palm portion of the glove. Pull the gloves on and make sure the gauntlet of the glove covers the wrist of your smock. Some areas require additional control and require taping the glove gauntlet to the smock with approved tape. Again, check with your contamination control engineer or manager for this requirement. Check yourself in the mirror to ensure you are dressed properly for the clean room. If entering the clean room with someone else, use the buddy system and check each other to make sure you are both properly dressed. You are now prepared to enter the clean room. Cleanroom gowning, ISO class 5 or 6.
So this is for 5 to... If
Gowning
the
for an
clean room of the
ISO
class
class
of the
5 or
5 to
6
6,
clean
then
room is slightly different than gowning up for an ISO class 7 or 8 clean room. Instead of a
See that-
smock,
that
a
5
full
to
set
that-
of coveralls or bunny suit must be worn. However, the same principle as before follows,
so in the 5
and the
to 6
gowning
class,
process
even
should
you
go
have
from
to
the
wear
top
that
down,
your
starting at the head.
pants or that also
First,
that in that
place
case.
the bouffant cap over your hair
Without
and
apron,
ears.
you are not allowed
Make sure the
that with
cap
apron.
covers all of your hair. People with long hair should tie their hair back before putting on the bouffant
So,
cap. Next,
it is a
put on a
complete
face
kit will
mask,
become-
completely covering your nose and mouth.
It will
The
be,
next steps are
we
different
use
from
the one
gowning
time.
up for an ISO
Cannot
class
be
5
used
or
that
6
many
clean
times.
room
Reusable
compared to
is
an
not
ISO
allowed.
class
Only
7
the
or 8
apron will be
clean room.
reusable.
Obtain a clean hood and open any bagging with scissors. Throw the old bag away. Place the hood over the head, on top of the bouffant cap and face mask. Adjust the cover using the buttons in the back if it does not fit properly. Be sure to choose a hood size that fits comfortably. Obtain a set of cleanroom coveralls, or bunny suit. Gather up the coveralls and sit on the dirty side of the bench. It is absolutely important that the coveralls do not drag on the floor while dressing. Carefully step into one leg of the coveralls and then the other leg. Stand up and put your arms in the sleeves, again making sure the sleeves do not touch the ground. Zip the zipper all the way up and secure any snaps at the neck. Tuck the bottom of the hood into the top of the coveralls. Make sure you have chosen a comfortable size and the coveralls are not too big or small. Choose the correct size cleanroom boots. Boots that are too large can cause a trip hazard. Carefully step into the boot.
So when the
The
size of the
disposable
clean room
booty
that
will
the
remain
class will
on your
be
shoes
that
and will
from
be worn
decreasing
inside the
that from
cleanroom
class 1
boot.
you have to more picture about that.
The leg of the
During
boot
the
is
empty.
worn over the coveralls.
Because that acceptable size
Secure
will
any
be that
snaps and
particles will
tighten
be
all
less in
straps
that
for a
case.
proper fit. Then swing one leg over to the clean side and then the next. Then stand up. Follow the same procedure for putting on cleanroom gloves, making sure to handle them by the gauntlet and avoid touching the fingers and palm region. The gauntlet of the glove will cover the cuff of the coveralls. Tape gloves as necessary for the requirements of your area. Finally, check yourself in the mirror and check your buddy if you have one. You are now prepared to enter the cleanroom. Working in the cleanroom. When entering the cleanroom, there might be another adhesive sticky mat in front of the door. Be sure to step on it before entering. When in the cleanroom, practice slow and methodical movements so as to minimize the amount of particles you release in the air by moving. Moving around quickly can introduce nearly 50 times as many particles as moving slowly. Be sure to check your gloves regularly for any rips, tears, or contamination. If
Now
your
that
gloves are
during
damaged
that,
or contaminated, exit the
since
cleanroom
that gloves will
and
be
change
that-
out of your gloves in the gowning room.
So she
Your
should be
skin
wear
can
new
introduce
gloves.
large quantities of contamination, so properly covering your hands is essential for protecting the hardware. If you have to sneeze or cough, be sure to do it facing away from the equipment. Do not cough or sneeze onto your gloves. Prohibited actions. While in the cleanroom, a
So
number of
these are
behaviors
things are
are prohibited
prohibited in
as
the
they
clean
introduce
room. You have
unnecessary
not to-
contamination.
Smoking,
Smoking is
applying
absolutely
makeup,
prohibited
eating,
in the clean
drinking,
rooms, as it introduces a
tobacco
vast
and
number
everything
of
should be not
unnecessary
allowed in the
particles
clean
into a
room.
clean room. Applying makeup in the cleanroom is also prohibited, as makeup is a
So
huge
when you have
source
to
of
enter the clean
contamination.
room, you should not carry any
Touching
food
one's
items,
face with gloved hands
any
introduces skin
smoking
and
and
oil to
that
gloves,
toxic
which then
item
gets transferred
with
to
you.
hardware and other surfaces.
You have not to do this
Removing
type of things
gloves,
as a clean
face
room is not
masks,
allowed.
or any cleanroom garments is prohibited in the cleanroom and should only be removed in the gowning room. And absolutely do not open your smock or coveralls to pull items out of your pockets, such as cell phones. Eating,
Like that you have to
drinking,
apply
and
makeup
chewing
and not
gum or
allow
tobacco
eating,
are not allowed in the cleanroom.
drinking.
Do not enter the cleanroom wearing street clothes. Only proper cleanroom garments may be worn in the cleanroom. Do not wear cleanroom garments outside of the cleanroom and then return to the cleanroom. This is especially true for soft wall cleanrooms.
Do you know top 10 countries for freelancers according to CNBC? I'll tell you. United States has 78% of freelancers.
So when you have to
United
leave
Kingdom
to
has
the clean room,
59% of freelancers.
you
Exiting
have
the
to
cleanroom.
pull out your gown
When
and
finished
everything
in the
that you have to
cleanroom,
wear.
your next step should be to degown in the gowning
When your
room.
work will be
The
finished,
degowning process goes in reverse order as the gowning process, from bottom to top. Here is the degowning process for an ISO 7 or 8 cleanroom. Take off your gloves and dispose of them in the
so
proper
you have to pull
receptacle.
out your gloves and everything
Remove
in the
your smock.
dustbin that it is
If you are
one
only
time
leaving the
usable only.
cleanroom for a short period of
And you have
time,
to
you can hang
pull
your
out your
smock in the
gown
cabinet.
and
If not, place your smock in the hamper so that it may be washed and reused. Remove the face mask and bouffant cap and dispose of them as well. Finally, exit the
So this
cleanroom,
is for the
take
class
off your
7
booties,
and 8
and throw
for
them
that.
away.
For 5 to
The process is
6
similar
it will be
for an
different.
ISO class 5 or 6 cleanroom. Once again,
So
take
it
off
is
everything
reverse
in
order
the reverse
that we have
order.
to take when you have to enter.
Remove
It is
gloves
completely
and
reverse
place them
order.
in the trash. Remove each cleanroom boot. Unzip the coveralls, remove the sleeves from your arms, and sit on the cleanroom bench.
Sorry.
Remove the hood. Hoods, coveralls, and boots may be hung up in the cabinet for a short period of time, if you will be returning to the cleanroom later that day. Otherwise, place the garments in the laundry hamper. Remove the bouffant cap and face mask and dispose of them in the trash. Exit the gowning room and throw the booties away. Special topics. Depending on the
So this is
project
the
and clean
special
room,
things.
special equipment and
If we
procedures
require,
may
we
be
can wear.
required. If you are required
Like
to wear
that,
an
this is
electrostatic
the
discharge
electromagnetic
or
strip,
ESD
so it will
wrist
be,
strap, the ESD strap must be
protect you
worn
from
on your
that.
wrist
If
under
there's
both
some
the
equipment
garment
will
sleeve
have
cuff
some electric
and the glove
discharge and
gauntlet.
everything.
If your
so
project
it will be,
requires safety glasses, be sure to put these
precaution
on
step
over
you
top
have
of your
to
face
taken.
mask and
This is
bouffant
the
cap and under
safety
your
glass
head cover.
you have to wear.
If your
because
clean room has an
some,
air shower, be sure
lights
to use
and
it
everything that
prior
will
to
be
entering the
harmful for
clean
you,
room.
body that for
This
eyes. So
shower
you have to
blows
protect your eyes.
pressurized
This
air
is
over
the
the
air
garments
blower
as a
that I
final
already
cleaning method
talk
to
about
remove
that.
particles
You have
before
to
one
sit
enters the
in,
clean room.
you have to
Only
stand
one
in the air
person at
blower
a
and it
time
will
may
be
use
suck
the
out
air
all the
shower.
particles and everything from your body.
To review, practicing proper cleanroom procedures is integral to maintain a cleanroom environment. It helps ensure the safety and success of a given project. When entering a cleanroom, you should dress up from the top down. While in the cleanroom, be sure to move slowly and deliberately and check your gloves regularly. When exiting the cleanroom, degown in the reverse order. This concludes Keeping It
So
Clean, how to properly use clean
in
rooms.
the video I have
Thank you
played
for
from
watching
that
and
Dennis
for following
Aranda,
proper cleanroom procedures to keep our
Dennis
sensitive
Aranda
science instruments
that
and
we have
spacecraft
uploaded,
clean.
so we are acknowledging her. Have you any doubt till now?
No, sir, no doubt.
Hello, sir. Good
Yes.
evening. Sir, I have doubt related to the size of particles, sir. Sir, how we define the size of particle in the clean room? Because the size would be randomly anything, sir.
This is the size formula.
Okay.
Cn equal to 10 to the power n into 0 to 1 d into 208. Where n is the ISO classification number, it should be 1 to 9. N is the diameter of the particle size. Okay, and already that ISO standards. So ISO class 1, that allowable size should be 10 or 2 particles. So 0 to 1 micrometer of the particle, it should be 10 particle per cubic meter, particle per cubic meter square, meter cube. Your particle size that will be allowable. I mean, this particle, if this type of the from that 0 to 1 10 particle will be available, then this is the clean. Okay, so in the class 9 said that in the 5 micrometer size, that 2,93,000 particle will be available per meter cube. So it is not clean, properly clean, but if the class 1 and class C, that you maximum size of the particle should be 0 to 5 micrometer. It is already 4 or 35, class 3 and class 4.
Okay, sir.
Okay.
Yeah, sir. But my doubt was is that how can we say that in this in that particular area that particular size of particle is existed, sir?
We that will be when we have to design or constructed the clean room. That time that we have to provide a detail to the vendors, and they have to put all the accessory and filter according to that only that.
Okay, sir. Got it.
Okay.
Yeah.
So we can give the specification to the vendor. So he will be during that construction time, he will take care that everything. Okay, this type of the particle size should be filtered by our HEPA filter.
Yeah. Okay, sir. Got it. Thank you.
Anything else?
No, sir.
Sir, what we have here in sense is class 1, right, sir?
Sense, not class 1.
It is of
5
which?
or 6 class, because it should be 10,000 that.
Okay. Mhm.
Class 1 should be used by the some industry like that Intel, AMD, that Taiwan people, they use that during that for system integration, and that time that.
Okay, it has to be
To
class
maintain the,
1.
to maintain the class 1, it is very costly, very costly.
Oh, okay.
Okay.
Okay. Regularly, what we do usually for sensors? Which class of?
It will be class 5 or class 6, 10,000 or 1,000 or 10,000 clean. Means 10,000 size of the particles will be acceptable in that case of that 0, 10 to 100 micrometer.
Okay, class 5 and class 6 are acceptable usually.
Yes, sir. So
Yes, sir.
Indian are class 5 or class 6 clean room in Indian research that.
Okay, thank you.
Class 1 will be used by the Intel only, that chip fabrication during that.
Oh, okay.
Okay.
Okay, thank you.
So Dr. Chandra, you are from?
No, I am from Karnataka itself. I had been to this sense actually. I had gone through this nanoscience, nanotechnology course actually for 15 days.
Okay, for that training.
Yeah. I was there.
Okay, for that equipment training, and then you have to handle.
I had been to this actually clean room and all.
Yes. So you have the hands-on experience of that
Yeah.
XRD, CVD,
Yes,
and FPSAM and everything, that XPS and.
yes. I have seen
Okay.
that.
So
Okay.
have you fabricated any device there?
No, sir, no, nothing actually. I was little, I'm into the medical field actually. So I just wanted to go through the things which are in detail. So I don't know about how to create the sensors and all. So dental field actually.
So you are the BDS.
No, MDS.
Okay. So you can join that. That IIT have restarted that medical and that engineering course that for PhD.
Which one it is?
That we have in the IIT Jodhpur, or some IIT have that IIT Delhi. Even I think they have started the that collaboration with that AIMS, and some they have started a PhD in the medical Meditech.
I have no idea, sir. Please, if it is there, please let me know. Send me the link.
Even our college have the center, that interdisciplinary center of the Meditech with the
Oh.
we have a collaboration with the AIMS Jodhpur. So with the AIMS Jodhpur, yeah, yes.
So, if you have any link regarding that in details of whatever you are saying, please let me know.
you visit the IIT Jodhpur site and you can where that you can check that PhD admission in the Meditech. So in the collaboration with the AIMS Jodhpur and IIT Jodhpur will be provide you the PhD in the field of that sensor or that anything that you want to do that in. So you have to work with the AIMS Jodhpur and IIT Jodhpur and you can finish your PhD also here that.
Jodhpur, right, sir? Okay.
IIT Jodhpur have that courses, even IIT Delhi with that AIMS Delhi with that.
And then,
IIT Roorkee have the collaboration with the IIT, AIMS.
okay. Uh-huh.
So you can try with that if you want to more about that how the sensor will be work, how to you analyze the data, how the sensor will be collected the data. Even you can design some equipment with that that will be helpful for during that your in the Meditech that you can design the equipment which will be you have to face the problem like that in the treatment of the patient.
Okay, sir. Sir,
Our
PhD will be of 1 year, 1 year or
no,
3
it is a
years?
4 or 5 year course will be there.
Okay. Uh-huh.
Okay. So you have
Okay.
to work with the both the you have to provide a one guide supervisor here IIT Jodhpur or one in the from AIMS Jodhpur.
Okay, fine.
Okay.
Thanks for the this thing, sir. Thank
Yes,
you.
yes. Even every IIT should have started that with the collaboration with the hospital or some AIMS to do the PhD in the Meditech
No,
technology.
actually, wanted how to create this sensor practically. We have no idea, right? Like how to create this sensor. That actually,
That's why that even that doctor have not knowledge about that how ECG will be take the data. They have just predicted that signals that what the signal will become and they just advise to the patient according to that.
that's it. That's
How
it.
the
No,
data
because
how the
depth knowledge.
data will be
Yeah. We don't know. We have no idea about it. That's
yes,
correct, sir.
yes. So that's why the ministry have started a new course that even that engineering student and medical student will be come with a collaboration and they have make the new devices design or even doctor will be understand that how the machine will be work and what is the data will be that so they can predict the data according to that.
Yes.
Okay. So
Thank
if
you.
you wish to, then you can join that courses also. Even some short courses, executive courses will be also some IITs will be there for Meditech student for 2 years
Okay.
and 1 year that diploma course is that.
Oh.
Okay. So when you
Okay.
visited some IITs, that old IIT or some second generation IITs, you got the lot of the courses will be now in the even IIT Madras will be also that one Meditech course will be that.
Oh.
Okay.
Okay. Actually, we have come along with this Rajiv Gandhi University. Through
Okay.
Rajiv Gandhi University of Health Sciences,
Okay.
we had visited this sense regarding this nanotechnology.
Yes. Because when you have to like that
We
in the
had,
end, like that in the Rajiv, like that, have you visited the microbiology lab?
yeah. I think we have visited microbiology as well as whole
The
sense.
Rajiv Gandhi Medical University microbiology lab will be there.
Yeah, microbiology, and I think we have visited this even complete. Our this thing was in sense itself.
So where you have to provide like that one is that transmitted electron microscopy TAM will be there.
TEM. Yeah. We have seen
That
practically. We
will be
have seen.
useful to diagnose of the bacteria and virus that time. You can
Yeah.
easily calculate the particle size and what type of the that cells will be there or bacteria will be there. You can see through the time that analysis.
Yeah. We actually undergone the. I mean, those things we have seen, but
Yes.
the making of sensors and how the actuator work, that we really don't know how it is.
You
So
can take the
little things got to know from this lecture. I'm very glad that you have come up with such a good initiative.
no, it is initiative to the NPTEL team because previously last after before the 3 years what that student will be they have no contact with the faculty member and whatever they have just see the video and just they have write the exam. But
Okay.
when the PMRF scheme will be launched and the aim of the PMRF student will be that they have to deliver their knowledge to the either to the nearby college or through the NPTEL have initiate one that we have to start the live section. So PMRF scholar will be interact with their student. They have to take their doubts, their issues, what is the issue with the faculty or course. So we can because they have not interact with many students because in this course around 500 students will be enrolled and faculty will be not free to take the one by one problem. So we have take the problem of the student either we have to solve from ourselves. If we have not, then we have to write to the professors, so he will be guide us or he will be write to you directly to in the class that these things will be. So it will be interaction class between you us and that students, so they can feel that yes they have the some interaction with the faculty or student, they have clear their doubts and they have more clear about that course that things. Otherwise to the see video and write the exam is just a finish of the 1 or 2 hours job.
Yeah, yeah, yeah. Thank you.
that, that's why this is initiation will be taken by the NPTEL team that.
It's a good initiative. Thank you, sir.
Yes, yes, and even we have the more around that two to 300 PMRP scholar will be teaching live section class and
Yes.
so. So what do you mean by the pressure sensor? Can anyone tell me that?
Pressure sensor?
What do you mean by the pressures? Have you in the 11th, 12th physics you measure that? How you measure the pressures? What is the formula to measure the pressures?
Force by area.
Force, force per unit area.
And what is the unit of that pressure?
Pascal.
Pascal.
And one other unit, Pascal is one, and another SI unit.
Newton per meter square.
Yes. So why we need the pressure sensors?
To find the atmospheric pressure.
Okay.
So many applications. Tire
Any example?
pressures in the
You can
vehicle.
see that real practical example to hear by you and everything.
The tire pressure measuring unit in the vehicle.
Yeah. Yes, sir.
How that will be work? When you have to, I think that Pritam, you have the car or anyone have the car and you go to the petrol pump, 1 meter will become to measure the pressure that 35 Pascal or 35, 30.
Yeah.
Yes, but these days they use some smart sensor also working real time with the device with the tires in the running car also. You
But
can check
that
in
will
the
that will be inbuilt with the car.
yeah, but
Like that,
they are
if
smart
you buy
sensor,
the
I think.
Audi, yeah, if you buy the Audi, Mercedes or like that car cost is above the 30 or 35 lakh, that car will be have an
No,
inbuilt
sir.
facility.
These days only the car around 10 lakh or they also have some.
Now they have introduced the pressure sensor that they have
Yes.
for tires and for vibration that they can check the vibration of the tire also wheel alignment also. So they have put that both pressure and displacement sensor on that wheel.
Yes.
Even that your bend in the wheel alignment, the displacement of the wheel they have to capture by the sensor and it will be display on that your cardboard that
Building.
displacement. Yes. Okay. So so pressure express the magnitude of normal force per unit area. So it is P by F units that different units that pascals, bar, atmospheric pressure like 700 will be the atmospheric pressure, torr or psi that pound force per square inch. So this is the conversion from the one unit to another unit that 1 Pascal equal to 1 nanometer per square, 10 to the power minus 5 bar. So this is just the conversion unit for your reference. So this is the applications. I think that my voice should be not audible. I am audible? Hello?
Yes. Yes.
Yeah, sir, audible.
Yes, sir. Audible.
Yes, sir. In between that, I mean that net connected. So these are the different units for your reference that all these are the unit of measure the pressures. So it will depend upon the applications or what type of they have integrated the sensor in the which form that. This is just depend upon that integration only that. Some people will be put the unit in the bar measure, some will be measuring the torque. So when you check that equipment, I like that I have explained last class that CVD and that sputtering. So they have to put the sensor and they measure the display value in the either torque or millitorque. Some will be in the Pascal form, some will be in the measure in the Newton per meter square. So according to users or that instrument, that unit will be changes. So this is the just the conversion of that things. So this is the applications of that pressure sensor, blood, brain, spinal fluid pressure. How do we measure? Like that blood flow in the microfluidic sensors, vessels, how much the flow should be, will be, how we can measure through that pressure sensors. How do we measure the hydrostatic pressure in the fluids or liquids? Like that in the turbo, that what is name that
Submarine.
Submarine.
submarine,
Submarine.
that how they measure the pressure, that when they have go to that they have in the depth, they have to go that the pressure will be more in the depth. So they have to maintain that everything that they have to start the engine to maintain that pressure, and everything will be displayed through the pressure sensors. Hydraulic system, arms, car disc brakes, hydraulic lifts, so they measure the pressure through that pressure sensor. So have you water tank in your home?
Yes, sir.
Yes.
So when the water will be like that, have you seen that that motor will be connected some sensor? So when water should be low, it automatically on. When water will be come through the that tank, it will be automatically off. That type of system have you in the home? That some alarm will be start that
Yes.
that tank will be full or tank will be empty.
Yes, sir. Alarm is there.
So it will be measured that either level, there should be either level sensor or some pressure sensor will be could put in that motors.
Yeah, level sensor in my
Ah,
home.
so so they are working on that level sensor. They are working on the distance. That how much that, so they use the LVDT sensor, linear displacement type sensor, that LVDT they have used, or like that that should the air tank, that how much that air will be left in the tank. So they have to measure the pressure of the air in the tank. Like that, if the air pressure of the with the fully tank should be like that 10 kg per meter cube square, then if the air will be using, and he will be continually measure that how much air will be left in that tank. So this is the liquid or gas pressure type sensor. This is the Pascal's principle. So measure that P is the unknown pressure, P is the ambient pressure. So fluid density, gravitational modes, fluid column. So how much the fluid, that when the pressure will be, so fluid will be move here and there, and it will be measured that how much the weight of that car on that. So uh, like that a truck will become with some material, so we have to weigh that material, at how much the weight of the truck, like that. And so we have to measure the empty truck weight, and then with the truck will be full of the some materials, we have measured the weight of that both the things. And like that you people buy the concrete or anything, then you have to measure the weight of that concrete, at how much the kg or that ton that concrete that brought by some truck. So this type of the sensors they have put in below that things, and then they have to measure that weight of the truck. This is the mercury pressure sensors. So this they have the fill the mercury here. This black is the mercury, and they have this is the OPM. They have used to measure the voltage difference between and the pressures. So due to the mercury, that flow of that current will be changed here. So the V output should be V delta R and V delta R by R. So they use the some U-shaped wire in the image into the mercury, which sorts its resistance in the proportion with the height of the mercury in each column. So voltage will be changed according to the height of the mercury. Okay. Any doubt?
No, sir.
So this is the piezoelectric pressure sensor. commonly that now used people that piezoelectric materials that have the property of the with the pressure the material property will be changed, either that structure will be changed, strain will be introduced in the materials, or some like that piezoelectric material, that alignment of that electron and hole will be changed, like that if the alignment will be like that of that materials, when the pressure will be applied here, it will be change their alignment like that, or it will be random abbreviated, or like that things will be happen. So the piezoelectric materials will be used. So this is the substrate, silicon substrate, that 100 type of the silicon substrate we use. And P plus Si means this is highly doped P type silicons, means P type materials, it is made of the P type, that P type materials, that aluminum, boron, germanium, that material will be made. And above that we have used one insulated layer, SiO2, and these are the piezoelectric elements like gold or silver, and these are elements, and we have to pressure the electrical field will be, difference of the electric field will be generated here. So we measure the pressures in the presence of in case of in particular field of that electric field. That so this is the fabrication part, that bulk micro machining will be used, MEMS technology, that bulk micro machining and small micro machining is the two different technology in the MEMS. So they have the cut here, this is the back side mask, this is the boron dope, this is the front sides, and they have the cut here. That so this is the P or N type of the cut will be happen for P and N junction, and after that they have fabricated that sensor, that pressure sensors. So this is the schematic or real image of that, this is the same image of the devices they have fabricated. So now we have to move to the stepper motors. Have you seen stepper motor? Anyone see the stepper motor?
Yeah, I have seen in some robotic
Robotic
application.
parts.
I Pritam, you have used in your lab like that.
Not in my lab, but I have used for one project for any. We working on some robotic arms, so we seen there. Robotic arms use this for some small motions.
Yes, yes. Have you visited in any mall in the Delhi or metro?
Mm, yeah,
So metro door will be automatically open. How it will be move here and there?
they use the stepper motors for that.
They use the stepper motor to move.
I
Okay.
think.
Yes, yes. So this type of the electromagnetic field will be generated. You can see that. So this PPT I have taken from the technology support subject service for your more clarifications. So this company will be fabricated that stepper motors. So see that this is the north and south pole, and you have to apply the electric field across the north and south pole, and the electromagnetic field will be generated, and rotation of the motor will be start. So the motion of the motor will be using that electromagnetic field, external electromagnetic field. So you have to attach one gearbox to move anything. So the motor will become in the like that 1 RPM motor, 1000 RPM motor, 1 rotation per minute. RPM full form will be rotation per minute. So when you have to, as per your application, you have to go to shop. You said that I need a stepper motor of the 100 RPM, or some people using a 1000 RPM or more. So RPM means rotation per minute. Means in 1 minute 100 rotation will be done. So as per your application, you take the stepper motors. So this is the rotor, and this is the starter, and this is the coils. Some electrical people have more knowledge about that rotor, starter, and coils, because I am from that electronics background. So they have more about that winding, that transfer coupling ratio of that N and N1. That they have more about knowledge that. So these are the schematic of that stepper motor. So this is the starter, that winding will be there. This is the rotor, one shaft will be there to rotate with that winding. This is the outside casing, and this is the pole, that two poles motor, that north and south, and these are two poles here. This is the cross section of the stepper motors. So this is the starter. They have some brushes here to heat sink. They use some brushes. This is north and south pole, and in outer side that they have generated the coil of that copper coil will be there for generation of that electromagnetic field. This is the four step per revolutions, that 90-degree step motors. So that two north and south, two magnetic will be used in that case. Two magnet that have the north and south poles. That this is the half step motors. So 45-degree take step will be taken, and 8 step per revolution means to complete the one 360-degree. So they have to take the 8 step. So half step operation will be there. So this is the winding number 1. This is the winding number 2. This is the 6-pole rotor, means they have the rotation of the 6 30 degree, 30 degree everyone. This is the one step. So like that 1, 2, 3, 4, 5, 6 step will be take. So this is the schematic, that how that is working, that 6 step electromagnet rotations inside that motors. So this is the practical step motors. See that the top electromagnet is turned on, attracting the nearest teeth of the gear shape. This gear will be, and this will be that have that either 60 gear, that teeth will be that either 66, and it depend upon the teeth that. So it will be a gear have also some teeth, and that will be rotate. See that this will be rotate with that electromagnetic field. So this is the stepper motor applications. This is the stepper motor applications and CNC lathe. CNC machine, lathe machine have the stepper motors. So when you are, if you have in the BTech, you have the first year, you have the lab of that basic of mechanical lab. Have you that lab, basic mechanical lab?
Yes, sir. Yes, sir.
In the workshop lab, the workshop lab, where you have to talk about that how welding will be done, how will be
Yeah,
cutting,
yeah, yeah.
how will be
Yes,
the
sir.
lathe machine will be used to groove and everything that. So in CNC machine we use the stepper motor. In the printer that you use the stepper motor. Your printer, laser printer and inkjet printer, use the that motor is that stepper motor.
Oh, yes, sir.
So this is this is the stationary coil, like that I said already, that copper coil will be there that. So this is the advantage, that low cost for control achieve ruggedness, simplicity. This will require a dedicated control circuit, more accurate than DC motors. So this is the control sequence to turn the stepper motors. So step 1, step 2, step 4. So it is a clockwise and it is anti-clockwise motion. That this is the clockwise and this is the counterclockwise, anti-clockwise. So this is the servo motor details. This is the gearbox and that reviews the peoples. So this type of motor used in the robotics. People are using in the robotics. So how you connected the Arduino? I saw one video that how people using through the Arduino. So this is the electronic. I think that they have. So this video they have here. This is the stepper motor here. I think you have to see.
Today in the workshop, we're going to work with stepper motors. We'll learn how
So this is
stepper
the
motors
control they
work and
use the stepper motor that.
what the difference is between a bipolar and a unipolar stepper. We'll also see how we can use a ULN2003
This is the Arduino. This is the Arduino board is available easily in the market. So if you have try with the control of the stepper motor, you can try in your BTech project or MTech project also to connected Arduino. Now people are connecting the IoT based sensor that they are already based on the Arduino board. So IoT based or AI and machine learning based sensor will be connected to the Arduino system only.
and an A4988 module to control our
So
stepper
this is
motors.
the connected that wire
It's a lot
the
to
Arduino
cover,
that
but don't
people are
worry, I'll
connected
take
with
you through
Arduino
it one
level.
step at
So
a
that
time.
movement of control
Welcome
of
to the
through that.
workshop.
So this is the potentiometer. We vary the resistance.
Hey, welcome to the workshop. We've used motors in some of our other projects before. We did a whole video on using brush DC motors along with an H-bridge controller, and we've also used servo motors in some of our projects, including the MeArm robotic arm, which made use of 4 servos. But until now, we have not done anything with stepper motors. Now, stepper motors are very valuable devices that can be used in a number of different applications. They're very good when you need a high torque motor. When you need a motor that can position something very precisely, a stepper is what you need. And also a number of stepper motor that moves in discrete steps. After each step, the motor holds itself in position. Consists of a magnetized geared shaft that is surrounded by electromagnets. This is stepper motor design. The variable reluctance stepper. These differences are in current to coils, which in turn creates that you need to be aware of. Of 2 sets of coils and usually has 4 wires, 2 wires per coil. The unipolar stepper motor also consists of 2 coils, but each coil has a center tap. Unipolar steppers can have 6 connections, but they often have.
See the difference of the. You can see the difference of that uniform and that bipolar stepper motor. I have asked the question that assignment also that how they have fabricated that design that constructed that uniform and bipolar stepper motors there.
Five, as the 2 center taps are tied together.
I think this is very long video.
Now internally, the coils in a stepper motor are actually split.
Hello guys, welcome to another video of Circuit Digest. In this video, I'll show you
This
how
is
you
the
can interface
video
a
to
stepper
control
motor
the
with
stepper
Arduino
motor,
Uno
interfacing
and
with
control
that
it both
Arduino.
in clockwise direction
So
as well as
this
in
is the
anti-clockwise
angle they have
direction
put.
by increasing it in terms of steps. As you can see, I have a circle here which starts with 0 and increments with 256 like 256, 512, 768, 1024, 12. 80, 1536, 1792 and all the way up to 2048. This means that I have to increment 2048 steps to make this stepper motor. These details can be found on a BLDC driver module with 4 LEDs.
So
These
how will
4
rotate
LEDs
that? They have
indicate
put
the
the
4
one
coils
paper
of
on
the
that
stepper motor. So
shaft
now I'll
and
show
it
you
will
by
be rotated
incrementing it by 1.
clockwise
You
and
actually can't see the
anti-clockwise.
stepper motor moving, but you may be This is on my webcam and I have displayed it on my
So this
computer
is the
setup on the
code
right
they
side.
have
So
used
whatever we want to show the
in the Arduino.
stepper motor visualize clockwise steps in the NPC
This is the
5
output monitoring that 520 and that rotation. So you can use that motor for your anything. This is from my side. Anything you want to ask something?
Hello, sir. Sir, I want to ask you a little bit debated question. Sir, I am a final year MTech student of optoelectronics and laser technology, and I have applied in a science department of IISc, sir. So, sir, what are the questions they can ask me related to sensor?
For MTech.
No, sir, for PhD.
So you are the MTech student.
Yes, sir. Final semester MTech student of optoelectronics and laser technology, sir.
So they will ask from that your first day you have to prepare your project that on what project you have to working on that MTech thesis.
Yes, sir. So, like currently, I'm working on design and modeling of gallium nitride based LED, sir.
Gallium nitride base?
Yes, sir.